Classifying chemical reactions and predicting their products. There are 9 categories of reactions that we will look at. First one, combination, is a reaction in which 2 or more substances produce only one product. First look at binary compounds. This is a combination of 2 elements. Will produce a binary compound, and we're going to predict the product by assuming the elements are in their most common oxidation states. So if I react lithium with nitrogen, which is diatomic, using the most common oxidation states, lithium is a +1, and N, most commonly, -3. That'd be Li3N would be the product, and then I could go back and balance that equation like this. Metal oxides like MgO react with carbon dioxide to form metal carbonates, the CO3. Metal oxides react with sulfur dioxide, SO2, to form metal sulfites, SO3, with a -2. You will notice that letter B and C are very similar to one another. Letter D, metal oxides react with water to form metal hydroxides, like Na2O reacts with water to form the hydroxide NaOH. And then nonmetal oxides react with water to form oxyacids. Now with nonmetal oxides, and I will give you a couple more examples, we have to have the same charges on both sides of the equation. So like N2O5, oxygen's a -2, which means nitrogen is a +5. So in the product, nitrogen has to be a +5. We cannot change oxidation states from side to side. So for example, if I have this nonmetal oxide, if I have N2O3 and I react it with water, I will also get an oxyacid, but it's not going to be HNO3. It's going to be HNO something. N2O3, the charge on nitrogen is a +3. So that means it has to be a +3 on the product side. Hydrogen's a +1, which means there have to be 2 oxygen with a -2. So this oxyacid would be HNO2. So the charges have to be the same from side to side. Let's say I have Cl2O7, that nonmetal oxide. I react it with water. I'm going to get HClO something. Go back to your charges, oxygen -2, chlorine would be a +7, so it has to be a +7 on the product side, which means I would need a total of 4 oxygen with a -2 charge. So HClO4 would be my product in this case. So pay attention to charges when you're doing non-metal oxides. Second type of reaction, decomposition. You have one substance that's broken down into 2 or more simpler substances. Opposite of combination. Letter A, decomposition of a binary compound produces the elements that make up the compound. So like Ag2O would break down into silver and oxygen, which is diatomic. Decomposition of a carbonate forms the metal oxide and carbon dioxide. Letter B, like CaCO3, forms calcium oxide plus CO2. Letter C, decomposition of a sulfite forms the metal oxide and sulfur dioxide. Now you'll notice A, B, and C are all the opposite of the combination reactions on the previous page. So if you know the combination reactions, you should know the decomposition reactions as well. Letter D, decomposition of a hydroxide produces the metal oxide and water. That's also the opposite of a combination reaction. Letter E is the only one that is not also a combination reaction. Decomposition of a chlorate, ClO3, produces the metal chloride, which is just Cl, and oxygen. And then letter F, decomposition of an oxyacid yields the nonmetal oxide and water. And again, with letter F, just like on the combination reaction, carbon would be a +4 on this side, so it's got to be a +4 on the product side as well. So make sure the oxidation states do not change with these oxyacid reactions. So if you know the decomposition reactions, you will know the combination reactions because they are exactly opposite. Third type, single replacement, is a reaction in which an atom or an ion is replaced by an atom or an ion of another element. We can recognize this type of reaction as an element with a salt or the reaction of a metal element with an acid. With the single replacement reactions, you have to go back to the activity series. In this activity series, the way it's written, Li is the most active, and it goes down that column. Aluminum is more active than zinc, and then it goes down this way. Tin is more active than lead, and it goes down this way. Now for the test, you don't have to memorize the activity series. I do want you to know the three most active, lithium, potassium, and barium. They will replace everything. And the three least active. So that's all I need you to know for the test. On the homework, you may be asked about any of these metals. You'll notice hydrogen is in the activity series, even though it's not a metal. So the different types of single replacement. Hydrogen displacement. Any metal above hydrogen will replace hydrogen. So if you go back to the activity series, cadmium is more active than hydrogen, so it will switch with hydrogen and we get cadmium chloride and hydrogen gas. Copper, however, is below hydrogen, so since copper is less active, no reaction happens. With single replacement, it is possible to get no reaction. You can have metal displacement. Any metal will replace a metal which is below it in the activity series. So zinc will replace copper because zinc is more active. The way I remember this is the more active wants to be in the compound. More active in the compound, always. And then finally you have halogen displacement. Halogen activity series just follows the periodic table. F2 is greater than Cl2, greater than Br2, greater than I2. And so F will replace any halogen. I will not replace any halogen because iodine is less active. So when we look at this example here, Cl will replace Br because chlorine is more active than Br, so they switch. But Br will not replace F because bromine is less active, according to the activity series. Okay, in this problem, write a chemical equation for the reaction of magnesium with a solution containing nickel 2 chloride. Nickel 2 chloride would be NiCl2 because nickel would be a +2. You want to go back to the activity series and see if this reaction occurs. Find magnesium, find nickel. Magnesium is more active, so magnesium will switch. So you get MgCl2, because magnesium is a +2, plus nickel. Fourth type of reaction, double replacement. A reaction between two salts in which the cation ions switch with each other. Now these reactions are ordinarily precipitation reactions, and the products can be predicted by knowing the solubility rules. So we have to go through the solubility rules in order to determine if these reactions will happen. So here are the solubility rules. Letter A, nitrates, chlorates, acetates. Anytime you see nitrates, chlorates, acetate in any salt, it's always aqueous, soluble. Letter B, anytime you see sodium, potassium, or ammonium, they are always aqueous as well. Doesn't matter what they're combined with. Letter C, chlorides, bromides, and iodides, just Cl, Br, I, of all metals, with some exceptions, lead, silver, mercury, are aqueous. And I've cut out some stuff under letter C. That's okay if you want to go ahead and mark that off on your notes. This is all you really need is this first sentence. Letter D, sulfates of all metals, except lead, mercury, barium, and calcium are soluble. And again, I've cut out some stuff there if you want to go ahead and mark that off on letter D. And the same thing with letter E. I've marked off some stuff there. Carbonates, phosphates, borates. And I've written out the formulas for carbonates, phosphates, borates if you've forgotten what those are. Letter F, sulfides, just S. Anytime you see the S of all metals except barium, calcium, magnesium, sodium, potassium, and ammonium are insoluble. That means they are solid. And then letter G, the hydroxides, the OHs of sodium, potassium, and ammonium are very soluble. Hydroxides of calcium and barium are moderately soluble. That means they are aqueous to some extent. And then all other metals are insoluble. So a double replacement reaction, we're looking for the formation of a solid. So let's look at a couple examples. And you do need to know the solubility rules because we need to know whether or not a solid forms. So we're mixing, in this problem, NH4Cl with calcium nitrate. And I always like to get the charges first. These are aqueous. We're going to go to the other side. One of my products is going to be NH4 with NO3, that's +1 -1. And then my other product is going to be calcium with chloride, and since calcium is a +2, it's going to be CaCl2. Now, in order for double replacement reactions to occur, one of the products has to be a solid. So we go back to the solubility rules. NH4NO3, well, it has ammonium. That means it's aqueous. It also has NO3, so that means it's aqueous. CaCl2, that's a chloride salt. Go back to letter C, solubility rule, letter C. And chloride salts, in this case, is aqueous because it's with calcium. So since both products are aqueous, which means dissolved in water, no reaction takes place. So unless there is a solid, no reaction is going to actually happen. So no reaction in this case for the double replacement. Write an equation for the reaction that occurs when barium chloride is mixed with aluminum sulfate. And both the reactants are aqueous. So we'll get the charges over here. And we're switching to positive, so Ba is going to be with sulfate. And then aluminum, which is a +3, is going to be with chloride, which is a -1, so AlCl3. Go back to the solubility rules. The only way this double replacement reaction will occur is if a solid is formed. Barium sulfate, that is rule letter D, is a solid. Aluminum chloride, that's rule letter C, is aqueous. And by the way, you can only have one solid for every reaction. So will this reaction occur? Yes, and there are the products for that reaction. And you can go ahead, then once you know the reaction occurs, you can go back and balance the chemical equation.